Welcome to the TWiML AI podcast. I'm your host, Sam Charrington. All right, everyone. I am on the line with Emily Bender. Emily is a professor of linguistics at the University of Washington. Emily, welcome to the TWiML AI podcast.
I'm really excited to be here. Thanks for having me on.
I am super excited to chat with you. We spent some time speaking earlier, kind of the obligatory, how are you doing, kind of age of Corona conversation, and kind of grounded on some of the things that we'll be talking about. Ethics, practical considerations around AI and NLP ethics, computational linguistics and a relationship to linguistics, to name a few. But I'd love to start with hearing a little bit about your background and how you came to work in the field of, linguistics / computational
Yeah,
linguistics.
yeah, happy to. So my background in terms of training is linguistics all the way. I
Okay.
studied at UC Berkeley. Didn't know what linguistics was until I got there, and heeded some wonderful advice the summer before going off to read through the course catalog, which back then was a book, looked like a phone book,
Uh-huh.
and just circle anything that looked interesting. And there was this one class called an Introduction to Language, and I thought, ooh, that sounds great because I really liked my language classes I took in high school. And so I circled it. And then when I was looking for a general education requirement class, saw that it fulfilled one of them, and so I signed up for it, and I was hooked on the first day. It was like
Mm,
this is my thing. But it took me the whole term to convince myself I could major in something that I perceived to be impractical,
mhm.
which is pretty funny in retrospect. Um, right?
And the
Um,
class was an intro to linguistics or?
Yeah, intro to linguistics.
Okay.
And I majored in linguistics. I took one computer science class when I was an undergrad. It was the intro programming class that was taught in Scheme, which is a
Okay.
dialect of Lisp. Um, and then I went on to do a PhD in linguistics at Stanford, where I worked
And did you
on
do field work in the whole nine?
um, no, I did some experimental work, but I didn't
Okay.
do like there's linguists who do really interesting work going out and recording people speaking to observe
Yeah.
sociolinguistic variation, or working with consultants to understand the structures of languages that are not well documented. And I'm not either of those,
Okay.
but I did do a little bit of experimental work. So my dissertation was on um, the interface between sociolinguistics and syntax.
Mm.
Right. So syntax is the study of what are the rules behind the grammars of languages. How do we get to um, the strings that are allowed and what they mean? Um, how do we write those descriptions, and what do we need to be able to create a formalism that'll work for any language? Because we know that any human can learn any language if they're exposed to it.
Mhm.
Right? Um, and so those are the questions of formal syntax, and there's this interest in what knowledge do we have. And then sociolinguistics is looking at language variation and how people speak differently in different contexts based on sort of their social address and how they want to
Yeah.
present themselves to the world.
So
Um,
register and all that kind of stuff.
yeah, register code switching,
Mhm.
right? Lots of people will have multiple different varieties that they control, and they use it to present themselves in different ways in different contexts, and,
Mhm.
and all of that. And the syntacticians were saying that's not linguistic knowledge. Linguistic knowledge is just what it is that lets you know that in English, we don't say I see cat, we have to say I see a cat, or I see the cat, or I see cats, right?
Mhm.
And that's a grammatical constraint of English. And that kind of stuff is knowledge of language. And all of this other knowledge that people have that allows them to decide when to speak in which way, that's separate.
Mm.
And my intuition was, well, we're one person, and yet we know all of this, and it's connecting to the same thing. I think it fits together. And so I did some research looking at variation in what at Stanford we referred to at the time as AV, which is an acronym, African American Vernacular English, also known as Ebonics.
Mhm.
Um, and Black English, there's a whole bunch of names for the variety, which is a surprisingly actually well studied variety of English among those that are not considered standard.
Mm.
Um, and so there's really good sociolinguistic studies of the ways in which variation is used in app to different purposes. And so I did a perceptual study looking at how people perceived the meaning associated with saying or not saying the verb be in different contexts.
Hmm.
So that's pretty far afield for a podcast on machine learning, but so that's what I was doing in my studies.
Yeah.
And alongside, I was working as a research assistant on a project building a computational grammar of English.
Okay.
Um, So I go on the job market and don't get picked up as either a syntactician or a sociolinguist. And so I go out into the startup world. I was working at a startup called YY Technologies. I
Okay.
started there in 2001, which was not a good time to be going into the startup world, if you remember.
Yep.
That was just in time for the dot-com burst.
Mhm.
Company was gone within 7 months of when I started working there, though it had been around for almost a decade.
Mm.
Um, doing grammar engineering for Japanese.
Huh.
Um, so building a grammar that modeled the rules of Japanese so that we could get from strings of Japanese to semantic representations in the context of a customer service application.
Okay.
Um,
Kind of precursor
the-
of a customer service chatbot?
yeah, yeah, it wasn't set up in a chatbot mode. It was meant to be email response,
Yeah.
but very much that same idea.
Okay.
And the company had a product that worked for English, and they wanted to branch out into the Japanese market. And so they hired me to work on the grammar for Japanese that would fit into that same product.
Huh.
Um, so then on the strength of that, basically, and a little bit of research I was doing around generalizing grammars across languages, got hired to start the professional master's program in computational linguistics at the University of Washington.
Okay.
Um,
Oh,
and
wow.
yeah, um, which felt like a huge stretch at the time, I have to
Uh-huh.
say. I was like, "Really?" Because if you look at my CV, I'm, pretty junior and I look like a syntactician/sociolinguist with this thin layer of computational linguistics on top.
Uh-huh.
But part of what was going on there was that the kind of syntax that I was doing was really, grounded in computational modeling of syntax. It was developed to be able to be written on a computer as well as understandable by humans. And so the linguists in my department saw all of my syntax work as computational linguistics too.
Mm. And was that
Um,
just the representation, the way you represented the syntaxes, or something about the analysis that you were doing?
it's about the analysis and the theoretical framework.
Okay.
So HPSG is what it's called, and it's a framework that's interested in getting down to all the details so that we actually model not just the small subset of sentences that are interesting, but everything you might find in running text eventually. And so that's very coherent with the goals of doing natural language processing, but from a symbolic perspective.
Okay.
Um, and on the other hand, it's very formalized. It's precise enough that you can do it on a computer. And a lot of other work that happens in syntactic theory is much more interested in theoretical questions to do with um, similarities and differences across languages, and doesn't put the same emphasis on getting down to the nitty gritty, both in terms of all of the data and in terms of precise enough a computer could do it.
Is there a
Uh,
way to create an example of the 2 different types that, would be
um,
illustrative?
it's not so the best examples I can think of are visual examples in terms of what the analyses look like.
Uh-huh.
Um, and just to give you a sense of it, when we build a grammar in HPSG for English, there's
Oh,
Euclid.
nice.
um, when we do that, for those people just listening, that was a cat that just jumped into the frame. That's why we're laughing.
And the cat did it earlier, and I was like, "I hope the cat does it again."
So there's the cat. He's helping me out. So in order to get so there's a resource called the English Resource Grammar
Okay.
that's the thing that I was involved with as a research assistant in the 1990s. It's been under continual development since 1993. It is a hand-built grammar of English on a computer that if you give it well-edited English text from pretty much any genre or register, so um, chemistry, academic articles, Wikipedia, Linux man pages, Norwegian hiking tourist
Okay.
brochures, like broad range of genres, but well edited. The cat just went flying. Um, uh, it can come up with um, correct analyses that give you a good grammatical structure and a good semantic representation
Like a
for,
syntax tree of the
yeah,
sentence or something like that? Okay.
syntax tree and then like predicate argument structure, like first order logic type representation. Well,
Okay.
predicate logic, not first order, of the semantics for something like 90% of those sentences.
Okay.
It's a massive project. But in order to do that, its representations internally are actually quite complex. And if we try to like print one out, not in sort of the abbreviated form that shows you the general structure of the tree, but all the details, it's pages and pages and pages for one sentence.
Hmm.
Right?
Mhm.
If what you're interested in is sort of making generalizations across languages about what happens with the expression of pronouns versus you just don't say the word at all in different languages, and how does that correlate with how much morphology is on the verb, that kind of representation can be cumbersome.
Mhm.
um, and so that's where the theoretical syntax tends to work more in broad brush, I think, than the kind of details you need to do it on a computer.
Hmm. Is there an analogy there to, like, explainability of machine learning models, or is that too much of a leap?
Oh, it's an interesting question. Um, but I don't think it connects to explainability because in both cases, it's humans are creating these things.
Yeah,
Um,
not directly,
yeah,
but, like, I'm
yeah.
envisioning the thing that
uh,
with the pages and pages is like
mhm,
a deep model with a lot of parameters that we don't really understand. I guess in this case, you
right,
can understand them if you zoom in,
right,
whereas
exactly.
in the other case, it's a little bit more amenable to interpretation.
Yeah, I think at that level, the analogy works. It's that
But it's not useful,
it's
that's
not it's
fine.
not quite true because you can drill down, but it's hard. So when people approach this
Yeah.
resource who haven't been involved with it for years and years and years, it is opaque, and it's like, well, how do I like why is this feature value this here and that there, and where is it coming from, and why did you make that analytical distinct decision?
Mhm,
There's a lot of work to be done still about how do we document this. It's an incredible resource, but how do we make it accessible and understandable to people who haven't already been deeply involved with it?
mhm, mhm.
So
And so
yeah.
did you end up taking another computer class?
Mm.
Programming class? How did you
That's a good question. I left that hanging. So I did take one class in the computer science department in graduate school. It was a class with Terry Winograd on phenomenology. It
Oh,
was a
wow.
philosophy class. We
Okay.
did not program anything,
Uh-huh.
um, and it was a great class. He made us read Heidegger,
Hmm,
which was painful. And but it was a really interesting class, and that's the only other computer science class that I took. I did learn along the way, you know, how to code. I done both work in the grammar engineering is a very high level programming language that's sort of
mhm,
declarative linguistic knowledge. But I've also done some work with some of the underlying algorithms. But I am not not the person who's going to build or deploy a machine learning system.
mhm,
Rather, my role in this dialogue about linguistics and NLP has been sort of saying, okay, I see what you're doing with the machine learning. How does that relate to the questions that we're asking in linguistics on the one hand? And that was sort of my first entry
mhm,
into it was, okay, you're building systems. I see the input. I see the output. I see you're really interested in the internals of the system, and that's cool. That's fine. But that's not the part that I'm working on, right? I'm interested in the framing of the task, the input, the output, how it's evaluated. Where did that gold standard data come from? How did you
yeah,
create those annotations? Um, and then how does that task relate to either scientific questions that someone interested in, say, how language works might be interested in,
yeah,
or how does it relate to the practical applications that you're selling it as a solution to?
right,
Um,
right. Yeah, you had an
so,
interesting tweet the other day. I meant to
uh,
look it up so I could reference it here, but it was something along the lines of I forget the exact framing, but a lot of your perspective being informed by the idea that, in NLP, we've got this whole field of linguistics that came before it, and now we're
yeah,
doing all this cool computational stuff. And that you contrasted that with computer vision, where maybe we didn't have
yeah,
computer visionology or whatever the analogous thing would be.
yeah.
What were you getting at there?
So that came out of a fascinating conversation that I had with Deb Raji and Emily Denton, who I only know because we've met over Twitter. And this is one of the
Okay.
wonderful things about this research environment, especially now that everyone's stuck at home. Is like, okay, yeah, sure, I have time to have a meeting with people who are in very different parts of the country.
Yeah.
Cool, right? Um, and they are interested in um, the sort of benchmarks and how they're deployed in machine learning broadly, and sort of where did they come from, how, and this is also Emily Denton's working with Alex Hanna on these questions of how does a benchmark become a benchmark? Why do people care about some and not others? Um, and I think we all share an interest in how do these benchmarks relate to the broader thing they're supposed to represent. Um,
Particular benchmarks generally, or benchmarks like ethics
yeah.
benchmarks, or
So it's a great conversation because all of the people in that conversation really care about ethics, but that's actually not what we're talking about. So it's just sort of always in the background informing it, but it's not the yeah.
I was just extrapolating from the names.
Yeah, exactly, you'd think. So, no, it's things like, so the super glue benchmarks for natural language understanding and ImageNet for, computer
Okay.
vision and image labeling, right? These become these, tasks that then you try different algorithms on.
Yeah.
And, so one of the things that came out of that conversation was, a framing that I really like, which is this sort of three-part thing. You have, um, the task definition sort of in the middle, and on the one hand, you have the data set that the task is represented by. And on the other hand, you have the thing in the world that the task is supposed to correspond to. Right?
Mhm.
So if your task is image labeling, and then you can say, okay, how does the construction of ImageNet actually relate to that task as sort of task internally that I'm trying to do? But then also, how would that task get deployed? What are we using image labeling for? And how does this particular conception of the task support or not support those use cases?
Mhm.
So we're
Interesting.
yeah. So we're talking about things like that. And in the context of that conversation, I was shocked to hear them say that from their perspective, NLP is better off than other parts of machine learning because NLP has linguistics keeping it honest.
Mm.
And I was floored by that because I feel like, yeah, that's what I'm trying to do. And there's a few of us in there, trying to have the conversation, but it does not feel like we're generally speaking being listened to,
Right.
which is maybe a little bit unfair. Um, I think the dynamic there isn't that people are like not listening or ignoring whatever, but it's rather that the way things are set up right now, NLP for some people serves as an application area of machine learning.
Mhm.
Right. So if what you're interested in is learning algorithms, and that is a wonderful area of research, I'm glad people are working on it. In order to test them and refine them and understand, what's good at what, you need things to be learning. And a
Mhm.
lot of people who are interested in learning algorithms seem to be interested in them as something that can learn generally. So they're interested in applying, RNNs in different contexts. And so you need
Mhm.
different contexts. And it's not just sort of a NLP view of, okay, different registers, different, are we doing speech recognition or machine translation? But language is one, vision is one, playing chess, things that you would need in autonomous driving. Like these are all different application areas. And so we get people coming into NLP who are really interested in the machine learning, and they're just coming to publish in NLP venues because they're applying it to NLP. And so there's
Mhm.
this constant influx of people who don't have um, long or deep training in either linguistics or really thinking about language. Um, and so I sort of feel like it's almost like chatting into the void, and then I talk to these other people who say, "Yeah, but at least there is linguistics, like, there's a field of study there, and what would it be for computer vision?" Um, and, I mean, I guess it's something to do well, the thing that's strange about it is that, yes,
And
there is
digital signal processing is the thing that comes to mind. We studied that in DSP
yeah.
classes.
Yeah, and that's used also in speech technology, right, for
Mhm.
the
Yeah.
speech recognition. But if you're looking at like trying to do what people do, and you're looking at
Right.
vision, um, there's something around both sort of perception. So how does the and here I'm talking way outside my expertise. Just want to flag that this is not anything I know anything about. um, how does the eye and the ocular nerve and all of that, like what happens when the light hits the
Mm.
retina and what
Mhm.
happens and then what happens in the brain that's processing it, to create maybe some sort of representation that just has to do with the visual stimulus, but then that
Right.
gets connected to categories of things,
Yeah.
right?
Yeah.
um, and so it's not just about sort of psychophysics and like
Mhm.
perception and stuff like that, but it's also about categories and ontologies and how we understand our world. And so I don't
Mm.
think there's one coherent field of study, like maybe it's different parts of psychology that they should be
Mhm.
talking to. Um, but I don't see that interaction apparently happening the way at least NLP and linguistics do talk to each other.
Mhm.
Um,
Interesting, interesting. Yeah,
yeah.
when I heard you initially describe the kind of how the, kinda your take on, machine learning folks, doing NLP, it almost sounded a little bit like you know, I guess most recently I've come across this in the context of COVID, like,
Mm,
data scientists running off building models and don't know anything about the virology. Like,
mhm,
does it
mhm.
feel to you as like you might be the virologist and you've got all these data scientists producing all these models that don't correspond to the thing that you actually understand?
Yes. And I had that same reaction to seeing the, data scientists jumping in around COVID. I'm really glad that you had
Mhm,
that panel on that, by the way. Those were great comments that your guests had, because there seems to be something in CS education, I think. It's somewhere
mhm.
in the people who are attracted to machine learning or the way we train them or both that basically says, "You are problem solvers. Here are problems, you solve them." Um, and Also, the way machine learning gets sold, there's this like packaging around it that's all about denigrating the work it's supposed to be replacing. And
Mm,
so, if we're going to apply machine learning to NLP, it's because, oh, it's far too expensive to do by hand, right?
mhm,
You wouldn't want to hire somebody to write a grammar when you can just learn a grammar, right?
mhm,
So it's better to do it automatically, and that has a way of devaluing the work of the people who actually understand the shape of the problem. And so
mhm,
part of my message as a linguist in NLP over these years has been, look, it's great to do things by machine learning, but if you want to know that you've actually done them, it has to be in conversation with people who understand the shape of the problem and can see whether um, your solution actually works.
mhm,
Um, and so when I see data scientists teaming up with virologists and epidemiologists and clinicians and saying, hey, I have skills. Where do you need my help? That's fantastic.
mhm,
When I see people jumping in and saying, I'm gonna solve this, and they seem to be on their own, I get really worried.
mhm, mhm.
Uh, and
And so, yeah, I don't know that things like language models,
yeah,
which have shown incredible,
right.
innovation and promise and all this kind of stuff of late. I don't know the extent to which linguistics were involved in their creation, but they're still interesting. Like, how do you kind of parse the fact that innovation is happening and we're doing, good, interesting, useful, at least in some cases,
Mhm, mhm,
things
mhm.
with kind of the viewpoint we previously discussed?
Yeah. Um, so there's a saying, and I wish I knew who to attribute it to, refers to the unreasonable effectiveness of n-grams.
Mm,
And this is
mhm.
this is before the transformers. This is old, right? You can
Yeah.
you can do a lot of useful stuff by just counting co-occurrences of words. And as a linguist, that's kind of a bummer,
Mhm,
right? Because when I look at a string of words, it's like, okay, yeah, the words occur in some order. Um, that's not the interesting part. But it turns out that if you have enough data and you count words and look at the orders they occur in, that's really useful. It's extremely useful for speech recognition. It's extremely useful for machine translation. Um, it's useful for information retrieval. So
mhm,
there's a lot there, um, and that's fine and it's useful. And it sort of comes back around to this: you have the task, and how does it relate to the world, right? So if your goal is better transcription of open domain in a noisy environment, um, and you've set up a task that well models that well, and you're honest about which language varieties are represented, and you don't claim to be solving speech recognition in general when it's actually speech recognition for a particular variety of English. um,
Hashtag Bender rule.
yeah, exactly. Exactly. That's all fine. And then there's interesting questions of, okay, why is that working? And there's room for linguistic knowledge to come in and say, okay, what is it that makes this effective? And also, let's do some error analysis. When it's not working, is there any pattern to that? Is there anything about what it's missing by only looking at sentences as strings of words that
Mhm,
can predict some of these things? There's a bunch of really interesting work going on right now under the rubric of Bertology,
mhm.
um, looking at the transformer language models and um, trying to figure out how much linguistic structure they are picking up by doing what's essentially just a language modeling task. And
Is
that's also
Bertology when you say that, is that the study of those models, or is it the, kind of the explosion of related models, Roberta and things like that?
so Bertology, I think I usually see it used to refer to the study of the models.
Okay.
So Bert and its kin, how is it that they're working and what is it that they're learning about language structure? So there's work by I can't do this off the top of my head. Sorry, I could look up references for you.
Mhm.
um, um, but people do probing tasks where
Okay.
they say, we're gonna take a slice of this model and we're gonna use it as a classifier, and we're gonna see if that model, just sort of as trained as part of BERT, has learned something about predicate argument structure, or has it learned something about syntactic categories or syntactic dependencies. Um, and
Interesting, and is that the line of, work happening primarily from a linguistic perspective or primarily from a machine learning perspective, or is it, both?
so the folks doing that tend to be teams of people who are um, all of them have an interest in linguistics.
Mhm.
I think primarily they tend to be folks who started off with machine learning training and then learned the linguistics. But some of them have linguistics earlier in their
Okay.
training, um, and then occasionally you'll get people who like bring linguists on as collaborators.
Mhm.
So that's I mean that's sort of. what I'm usually pushing for when I'm saying, that you can't do machine learning without domain expertise, it's not a kind I sometimes get accused of doing gatekeeping, which is not my intention. I think
Mhm,
that, collaboration is great, more perspectives is great. What I'm seeing is a lack of inclusion of the domain expertise perspective sometimes in the machine learning work.
mhm.
Um, the
And when you look at something like BERT with the linguistic perspective, is there kind of a laundry list of obvious things that, you think need to be done or that, should be looked at or that, things that, shouldn't have been done like that? Or, and I'm wondering how is it um are you speaking primarily out of kind of opportunity? Like if we pull domain experts in, then hey, maybe we could achieve some, greater thing, or is it because of the specific things that you see when you look at BERT? Well, and its
yeah.
kin.
Yeah. Um, so I can't say I have specific examples off the top of my head, and it's not. I mean, this is a soapbox I've been preaching from for years now, like pre-Bert, right?
Yeah,
Um,
pre-BERT.
and pre-Bert, it's more about the claims of what's happening, right? So if someone creates Bert and they say, "Hey, this is helping me do great speech recognition. This is helping me do
Mhm.
great machine translation," um, and then you can test that. That's a product. That's a sort of a practical application, and it works
Right.
better. Excellent. If somebody is saying, "Hey, Bert understands language,"
Mhm.
um, then that's a scientific claim, and I want to say, okay, show me what your um, tests are that allow you to make that claim that it understands language, and also I can tell you on first principles that it doesn't. Um,
Right. Right.
right?
And you talked
But
about this in your paper, Climbing
the-
Towards NLU on Meaning, Form, and Understanding in the Age of Data.
yeah.
And the basic premise there is that BERT isn't at all trained on meaning, so there's no way that it could display, meaning or understanding of meaning.
Yeah. Exactly, exactly. That was a super fun paper to write with Alexander
Uh-huh.
Kohler. We had a blast. And it came out of actually Twitter arguments. So I had this, I think it was back in the end of 2018, this unending Twitter thread. Thread is the wrong word for it, so that makes it sound very linear, and it
Mhm.
wasn't. Where I was basically stating the thesis of that paper, which is that if your training is only language modeling, so all of the training data is only form, and your task is to predict the next bit of form or in BERT style masked bits of form in the middle. Meaning, as you say, wasn't in the input signal, so you're not learning meaning. And there was an unending parade of people who wanted to pick up the other side of that argument with me on Twitter. And
What
um,
can you paraphrase was there a best of those arguments? Because when I read that, I have often been in a situation of trying to explain to people, technical or non-technical, whatever,
Mhm,
um, the the extent of these models and what they're really capable of and what they're not capable of, that kind of
mhm,
thing.
mhm,
And I really appreciated the idea of, hey, we're not the input is not meaning. It's not
mhm.
understanding, so that's not going to be what comes out.
Yeah.
Um,
So I don't have a best of, because it is sort of this like, it's not there, so how are you going to learn it? But it tends to take the form of, well, but what if you give it lots and lots and lots of data, right? Or sometimes the arguments
I
were,
think if I were to try to argue against that, I would try to say that meaning actually was there, but not in the form that you're used to seeing it. Like in a quality, but rather implicit meaning as opposed to
so
explicit meaning.
yeah, so that is one shape that the argument sometimes takes, which is, well, the sentences themselves represent meaning.
Mhm.
And that one is, well, yes, they do, but only if you know the linguistic system behind them so that you can pull it apart.
I was
Um,
gonna say this is the Sam gets creamed by a linguist segment of the interview.
so at the end of the paper, we actually have a bunch of the counter arguments, and we're like,
Okay,
you might say this, but you might, and so it's in there.
got it.
But part of what makes it difficult is we have to really pin down terms, right? So what do we mean by meaning? Um, and then what
Mm,
do we mean by language model? Because you
mhm.
can certainly imagine language models that are modeling meaning as well as form. So we say, okay, language model is the only input data it has is the form of language, and that could be the written form, it could be spoken, it could be signs and signed language. Um, like that's all it sees.
Mhm.
And Meaning is a relationship between those linguistic forms and something outside of language.
Hmm.
And we actually break that down into two parts. So the sort of biggest relation is between the form that I say and my communicative intent. I'm trying to communicate something to you. So, for example, when the cat went jumping and we're both laughing, and I'm thinking of the people listening to this, like when they're out running, like was how I usually listen to your podcast. I thought, oh, wait a minute, those people don't know why Sam and I are both laughing. What's going on? I better say something to clue them in, right? So I have this communicative intent to make apparent to these people who are only listening audio that there was a cat in the frame, right? So that's
Hmm.
what I want to get across. And so then I figured
Clearly, you're
out.
a better podcast host than I am because I was just laughing.
I actually have a lot of experience with online teaching. Um,
Mm.
we've been doing our classes not just recently. In the master's program, we've had classes in a hybrid online and person format since 2007.
Oh, wow.
Um, so I've long years, decades almost of experience with this now.
Got it.
All right, so cat goes flying. I want to get that across. So then I think, okay, how can I convey that to somebody who's listening? And then I pick a string of words that um, doesn't directly contain "cat flies over my shoulder," right? It doesn't. It doesn't. It's not a picture. It's a string of words
Hmm.
um, to provide a clue to the listeners that would allow them to reconstruct my communicative intent.
Hmm.
Um, and so the thing about language is that it is this collaborative experience. And interesting, like you and I are doing some collaboration right now, right? And we're doing a lot in terms of the general communication stuff, the turn taking. It helps that we can see each other,
Yeah.
right? It makes the turn taking way smoother. But we're also collaborating with our listeners. So
Hmm.
people who are not here in this present moment, who are listening later, hi people. Um, they are working with us across that time to work out, okay, given what I know about English and what these sentences can conventionally mean, what is Emily trying to get across to me as a listener? What is Emily trying to get across to Sam in the moment, and vice versa?
Hmm.
So that's what we're saying meaning is about. And hopefully that makes it clearer to people that it's not there if all you have are the pixels on the page.
Mm.
Right? Um,
Are you aware of any efforts that are trying to get there? Me,
mhm,
I'm envisioning something like, I mean, I guess we're all trying to get there, or everyone that's in this research field of NLU is trying to get there in some way. But more specifically, I mean, I'm envisioning something like a cross between a BERT that's kind of engram focused and a neural machine translation that is pairing, meaning and sentences.
mhm, mhm.
Anything
Um,
interesting happening there?
So, yes, and I think that a lot of the ways in which BERT gets deployed, you have the pre-training, which is just language modeling, and then you have the fine-tuning, which is giving a tiny little signal about the kind of meaning that's relevant for the present task.
Mm-hmm.
Um, and so it's there in that sense. There's a wonderful paper, this paper by Jonathan Bisk and colleagues, is talking about sort of the stages of the world scope of NLP. Um, so really early on, you might have had just like hand constructed word lists, and then you got
Hmm.
to corpora. So things like the Penn Tree Bank, which has Wall Street Journal plus the Brown corpus in it, and that's a couple million words of text.
Hmm.
Um, and then you get to like web scale, so enormous corpora, but it's all of that is still just form. And then they're saying, well, where could we go next? And so there's starting to be work on um, embedding the the natural language processing system in some sort of embodied context, where you are talking with a robot, and the robot has to figure out what motions in the world it should be taking.
Hmm.
Right. So there's small amounts of text, large amounts of text, text plus embodied interactions and grounding in things like vision and whatnot. And then the biggest one is adding in the social.
Okay.
Um, and so I think that's a really fantastic vision. And I'm super excited. This is not actually an ACL paper. It's a preprint right now. I think they're going to keep working on it and publish it somewhere else later. But ACL has this wonderful theme this year. ACL is the Association for Computational Linguistics. Supposed to have been in Seattle in July. And I'm sad that we don't get to host people in person. They'll be online. And the theme session is taking stock of where we are and where we're going. And so there's a bunch of papers sort of looking at,
Oh, interesting.
how do we go? And a lot of them seem to be focused on meaning and semantics. So
Hmm.
people are thinking about it.
And do you think that particular theme is driven by the kind of recent progress with BERT and the like, or is that, something that we
Oh,
talk about at these conferences every once in a while? Like, I
um,
guess I'm trying to get a sense of, does it feel from a linguistic and computational I guess as a linguist,
mhm.
and then maybe the next level is computational linguist, does it do you have the same feeling of excitement around what's happening, with BERT and language models and the like, as folks from the machine learning perspective have? Because I think from the machine learning perspective, it's kind of akin to 2012 with deep models and computer vision. It's like, wow, we're making a lot
Mhm,
of progress here. Or is
mhm,
it
mhm.
just dread?
So it's actually, as a computational linguist in NLP, it's kind of Schadenfreude actually. Because when I entered the field, the what I was doing was considered very old school, right? So I came into computational linguistics in early 2000s working on grammar engineering, and that was already the height of statistical processing in NLP. And so everyone would frame their papers as, well, in the olden days people would have to do this by hand, but now we can do it automatically. And I'm like, some of us are still here, still doing it by hand, and that's okay to have both. Like, we don't have to, there's room, there should be, the world is big enough for all of us, right?
Mhm,
Um, and then when deep learning sort of swept through NLP starting in about 2015, 2016, a bunch of the statistical learning people who had built up all this expertise around feature engineering were told, oh, no, 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 you don't have to do that by hand anymore. We can do that automatically. And
mhm,
so that's where the Schadenfreude comes in a little bit. But so it's not, there was a period where it got a little boring, because basically you had all these existing tasks, and turns out you could bulldoze them all with BERT. And so there's all these papers that basically take
mhm,
existing tasks, add first word embeddings in general from like Word to Vec or something, and then BERT into the mix. And hey, look, state of the art paper. And it's like,
mhm.
does anybody actually enjoy reading these? Like what do you get out of this, right? Was
Mhm.
was my reaction to that. So Bertology is really welcome. The people who start saying, okay, but why, right? What
Yeah.
is it about the pairing of this methodology and this task that makes such a big difference? That's interesting. And sometimes it is, hey, look, inside of the deep neural net, you can see that this layer is picking up this kind of information. And then that sort of opens up questions of, okay, so why is that information available just from distribution and text? Like,
Mhm.
those are scientifically interesting questions to me. And in other cases, there's a great paper by Neven and Cow at ACL 2019 that said, actually, guess what? BERT is cheating. And
Hmm.
we can construct a data set that sort of hides the clues that BERT was using that were just artifacts, and then it falls to chance. Um,
Really?
yeah.
Interesting, and can you elaborate on that a little bit more? I haven't come across that paper.
So this,
Or
and
maybe I
so
can should just interview the author.
yeah, that would be great. I would recommend it. But in brief, my non-author, non-expert understanding of it was that there was this was a question. I think it was like textual entailment or reading comprehension or something. And the
Mhm,
way the task was set up, um, the uh, there was artifacts in the data that made particular words really good cues for a certain kind of answer.
hmm.
And if you construct a data set that um, washes that out, then those cues are gone, and BERT doesn't do well at all. Um,
So it
which
wasn't necessarily a general statement across all tasks, it was for a particular
For a
task.
particular task, yeah,
Got it.
exactly. And
Okay.
it was sort of saying, "Hey, look, state of the art with BERT, yay! But wait a minute, that makes no sense. Why should
Mhm.
BERT be doing well in this task? Let's look deeper." And for that task, they found that problem.
Okay.
Um,
Interesting.
yeah, and
Interesting.
I think that that kind of result informed the design of superglue. So Sam Bowman and his colleagues are there was the glue task that had to do with language understanding, and then superglue was, okay, let's bring together more tasks, but let's pick the ones that are hard for BERT.
Okay.
Um, so I think that's a promising way to try to push towards um, tasks that better represent the questions that we're interested in. But you
Mhm,
asked, why do we have this theme at ACL? And I think you'd really have to ask the program chairs. So that's Joyce Chai, Natalie Schluter, and Joel Tetrol,
mhm.
who are the incredibly hardworking program chairs for this conference. And early on, they said, hey, it will make this more interesting if we solicit papers on this theme, if we actually encourage people to sort of lift their heads up and look a little bit more broadly at what's going on here. And I think I recall them saying that that was actually because of the date, basically. It was like, hey, 2020 round number, it's
Mhm.
time to like sort of take stock and think about it more broadly.
Got
Um,
it. Got it. Um, Interesting. So I'm trying to think if we've kind of fully captured the relationship between linguistics and computational linguistics, or maybe that's not possible to do now. We've certainly
Yeah, probably not possible in an hour, but I think that there's lots of ways in which linguistic knowledge can inform work on NLP, and it doesn't have to be directly in terms of encoding the linguistic knowledge in the system. I mean, when I
Mhm,
do grammar engineering, that's what I'm doing, and I think that's a valid mode of research, but it's not the only mode of research. But it's also not the only mode of research that needs linguistic knowledge.
mhm,
So if you're doing statistical machine learning or if you're doing neural processing for NLP, there's still room for linguistics on the one hand in feature design, if you're doing, the kind of thing where you're not trying to learn your features automatically. Um, but especially in task design and error analysis, and in understanding sort of the task data set connection and the
mhm.
task world connection.
Yeah.
And we barely talked about the ethics stuff at all, but there's a connection there too, because one of the things that linguistics tells us from sociolinguistics is that variation is the natural state of language, number one.
Mhm,
Number two, the fact that variety is anointed as the standard is all about power and nothing else, nothing
mm,
inherent to the
mhm,
variety. And so that means that if you've got technology that's working for the standard variety and not others, then you are likely to be setting up a situation where you're further disempowering marginalized people.
mhm,
So there's a lot that linguistics can do to inform the ethical deployment of NLP, especially sociolinguistics.
mm. And
Um,
is your research in this area looking at I know a big part of it is trying to understand how to engage with people around this idea of ethics
mhm,
and NLP. Are you
mhm.
also looking at the kind of fundamental problems themselves?
Um, so the fundamental problems are broad and diverse, and so I am interested in understanding, like as we sort of get these case reports of what's gone wrong or what might go wrong. I'm always interested in how that connects to language variation.
Mhm,
So when I think I mentioned to you beforehand that I've got some unpublished work trying to do a typology of the kinds of risks of adverse societal impact of NLP, and that is very much informed by what I know about language variation. Um,
okay.
so yeah, so working on that, but also
And
working on yeah.
does unpublished mean that you can't talk about it yet?
No, it just means that I can't point to anybody to it.
Got
It's
it, got it, got it.
yeah.
So,
But
when you what are some of
mhm.
those categories?
So I'm looking at it in terms of direct versus indirect stakeholders, and this comes out of
Okay.
value sensitive design. So work of Batya Friedman and colleagues, sort of conceptualizing the people that we need to worry about as both the users, the people who actually interact with the technology directly, and other people who are affected.
Mm,
So sort of
mhm,
taking that as the overarching thing, and then thinking about the different ways that you can interact with a system as a direct or indirect. So the direct stakeholders might be doing it by choice or not by choice, and then the indirect stakeholders, it could be, well, my words are part of a broad corpus, or I am a person who's subject to societal stereotypes that the technology might be perpetuating, um, or dang it, I got a third one over there right now that I can't do off the top of my head. But that's the kind of category, and none
mhm,
of those are specifically about sociolinguistic variation. But rather within each of those, I say, okay, if I'm a direct stakeholder choosing to use something, but it doesn't represent my language variety well, what
mhm.
happens? Right? So that's the
And so
sort of
what's an example of that?
so uh, the speech recognition does not work well for all Englishes.
Mm, mhm,
And so if I'm trying to use a virtual assistant and it doesn't recognize my variety, or it only recognizes the variety that I code switch into, usually outside the home, but I have to use it inside the home with this virtual assistant. How does that make me feel about my language and how I fit into
yeah,
the world, right?
yeah,
Um, so there's things like that.
okay,
Um, so I felt like I was going to go somewhere. So sociolinguistics informs that. Um, and I think that that's an important kind of linguistics that needs to be in the conversation and visible to people who are working on machine learning and NLP. And I think it's pretty remote. Like it's not the sort of thing that maybe people even necessarily know about. They may have heard of linguistics and they think of linguistics as like Chomsky,
mhm,
maybe. Um, so
mhm. Um, And so when you talk about kind of techniques for getting folks to engage in these kind of discussions and think about these issues,
Mhm.
are you primarily thinking about or targeting kind of the lay people or researchers and builders?
Um, so both, and I can give you a pointer to a video of a talk that I gave on this, and it sort of ends with whose job is this, right?
Yeah.
And I've got a bunch of categories of people, and we all fill multiple categories. So the first one is the researchers and developers,
Hmm.
right? Then there's consumers. So when we use a product, we either buy it or we just choose to use it in a like paying with our eyeballs kind of a way.
Hmm.
Um, the third one is procurers, so people who decide to buy and install and stand up a system
Hmm.
based on NLP or machine learning technology more broadly, I suppose. Um, then we have the role of members of the public who are advocating for good policy, and then we have policymakers.
Okay.
So you can see that any individual might be in multiple ones of those roles. And I think it's important to sort of get this knowledge out in all of those ways.
Hmm.
And so that includes, public engagement, things like this, right?
Right.
Um, it includes teaching. So I'm running a tutorial at ACL this summer with Dirk Hovey and Xander Schofield on integrating ethics into the NLP curriculum,
Okay.
so that people hopefully early on in their training will start to see this stuff. Um, and then, yeah, talking about it, sort of on Twitter, say.
Mm. How well do you feel the core like failure modes, ethical failure modes of NLP, not even to mention machine learning, but NLP are
Mm,
understood. Like I think we throw around the example, like these word to vec examples,
mhm,
man is to doctor as woman is to whatever,
mhm,
and those I think we understand those failures pretty well, or at least conceptually.
mhm.
But I'm trying to think of other ones that I've heard thrown around, and they are very few.
Yeah. Um, so they're right. So you have a one failure mode. Failure mode. I'm not. So it's one of these like it's actually working as intended, and we don't want that kind of failure mode, right? So of these, when the word
A
vectors pick
feature,
up.
not a bug. You commented on that, podcast
Yeah,
recently, right?
yeah, I love that episode. So yes, exactly. So it's like that. It's a feature, not a bug, because it's doing what we told it to do, and maybe we need to rethink what we're telling it to do,
Mhm.
right? Because there is an awful lot of um, bias in our conceptualization of the world that comes out in how we talk about the world. And then
Right.
if we say learn the patterns, guess what? That's one of the patterns,
Mhm.
right? And it's not even necessarily a pattern in the world that it's learning; it's a pattern in how we talk about the world.
Mhm.
And I think that a mistake that often gets made in these discussions of machine reading, natural language understanding, is that the text is the world, and it's not.
Mhm.
It's how some collection of people decided to talk about the world. So there's a further distinction there.
Mhm.
Um, so that's a quote unquote failure mode. You have cases, right? I mean, it's great because it's a feature, not a bug, but we don't
Uh-huh.
want that feature. Um, you have uh, cases where the system just doesn't do the thing it's supposed to do, right? So speech recognition and it gives you gibberish instead of what the person said, or speech
Mhm.
recognition and it just doesn't give you any words for a little while.
Mhm.
Um, machine translation and it gives you something that maybe sounds perfectly fluent because the language model's doing its job, but is a bad representation of the source language intent. Right, and that's, I think, a particularly insidious kind of failure mode because you don't know that it's failed. It looks fluent. And so if
Mhm.
as a consumer of that technology, you're not savvy to the fact that it's just making a guess, you might believe that the person whose words you've translated actually said the thing that you're reading when in fact they didn't.
Mm. Mhm. Interesting, and then, so what I'm hearing here is, you're saying things that sound like systems or models just breaking,
Mhm,
but then when you take those and, put those, let's call them technical failures into the world,
mhm,
they are having effects and that creates ethical issues, but they're also potentially caused by things like the, style of language that someone's using or accents or things like that. And that also creates ethical issues.
mhm, mhm, mhm.
Um,
Yeah. So the general framework that I am working towards for thinking about this is basically whenever we are moving away from this is a fun abstract toy that we're playing with to this is something that's going to be in the world, we have a responsibility to think about a few things. And one of them
mhm,
is what are the failure modes? That's the question you're asking.
mhm,
Another one is when this is working as intended, who benefits and who's possibly harmed,
Mhm.
and when it's not working as intended, um, who is harmed, because those harms are not going to be evenly distributed.
Mhm.
um, in many, many cases. So this thing about sociolinguistics and the fact that people speak differently and that people who are marginalized tend to then be told that their language variety is not standard and it's not the one that's getting modeled means that when the system fails to work because of a difference in accent or linguistic variety, that's going to fall differently across different groups of people.
Right.
Um,
Right.
but I have to always, when I get down this part of the line of reasoning, um, refer to Alvin Grissom's talk that I heard last summer, where he said, sometimes working as intended is really not anything we want, and so sometimes it's better to have it not work for you, right? If it's being used for surveillance, then you're happy when it can't understand you, provided that it's not understanding you just means it says there's nothing here, as
Uh-huh.
opposed to misunderstanding and then attributing, bad intent when you've said something completely innocuous.
Right. Right. I'll refer folks to my interview with Alvin from February of last year,
Mhm.
Pathologies of Neural Models and Interpretability.
Nice.
Great talk. Um, so when you talk about, again, kind of going back to this promoting engagement around these issues, part of the challenge I think is, um, generally getting folks to care about impacts on classes of people that don't involve them. Like,
Mhm.
is that something that study, or at least study the people that are studying that, and can kind of talk about how folks are thinking about that, or who we should look to.
So I don't have the expertise there. I can tell you just what I've learned by teaching this stuff. So I can tell you sort of my own experience reports about talking with people about this. But
Mhm,
you're absolutely right that we should be looking to, um, people who know about movement building and about sort of
mhm,
bringing people in, towards working towards shared causes like that. And that's not me.
mhm,
Um, but certainly, like there was a wonderful podcast episode of Radical AI with Ruha Benjamin on, and she had wonderful things to
mm,
say about
mhm,
how to connect with existing work going on in the community rather than thinking you're the one solving it.
yeah,
So I think there is expertise out there that should be called on. What I've seen is that um, most people that I talk to, and sample bias, I tend to talk to people who are interested in this. Um, Most people that I talk to um, would like to be sure that the technology they're creating is making the world a better place and not causing harm, and sort of feel uncomfortable with engaging with these issues. And so it's easier to just not think about it. It's easier to say, oh, I'm only working on the algorithm. And so one strategy is to say, well, what can you do to make it a little bit better? And that's where we're going with the data statements work is
mhm,
if you make clear documentation of what's in the data, then you have set it up so that people can say, hey, guess what? This is or is not a good match for my use case.
mhm,
And so that's sort of a positive step that's also close to our own research expertise as data set creators and ought to be close to research expertise as system developers who are using the data, right?
mhm,
You'd better understand what's in that data set that you're using to test the machine learner if you're going to claim that you're solving some task.
mhm,
So all of that I think is very in domain and a positive step. And my hope, and this is now just like pure speculation and hope, is that
mhm,
when people feel like they can do something like this, they then feel more attached to the longer term goal of making sure that they're building things that don't exacerbate inequities and maybe actually start being a force for good overall.
yeah,
Um,
yeah. And you just mentioned the data statements, right? And
yeah.
when I haven't looked into that in detail, but when I hear that, I'm envisioning something very similar to the data sheets for data sets work
Yep.
that Timnit Gebru
Hmm.
has done.
Yeah.
Is it similar to that? What are the key differences?
Absolutely similar, and in fact, it was sort of like there was something in the air in 2018. So
Okay.
you have Timnit's group doing the data sheets, Meg Mitchell's group doing model cards,
Yep.
and there was another group at the MIT Media Lab doing something called nutrition labels for data sets.
Ah.
And yes, absolutely very similar ideas. I think the thing that distinguishes data statements is that it was very focused on language data sets. So we were thinking about what do you need to document about a language data set. The data sheets work is absolutely wonderful in terms of thinking about what do you need across machine learning data sets broadly, and very, very congruent.
Mhm,
And I think, I mean, maybe Timnit and Meg were talking to each other, but there was sort of this moment where we all kind of looked around and went, "Oh, same." So yeah, absolutely, absolutely, that sort of the same idea.
Got it.
Yeah,
Got it. Awesome.
yeah,
Well, Emily, it has been
yeah,
so wonderful having an
yeah,
opportunity to chat
yeah.
with you. Any parting thoughts that you'd like
Um,
to leave us with?
this has been a blast. I'm sorry we only saw the cat the once. And I really, I hope that your listeners are remain interested in both how do you create a clever machine learning solution, and how do you think about how it fits into the world.
Mm,
And if that second part is hard, then who do you need to talk to figure out how it fits into the world for the particular task that you're working on.
great. Great. Thanks so much.
Thank you.
All right, everyone, that's our show for today. To learn more about today's guest or the topics mentioned in this interview, visit twimlai.com. Of course, if you like what you hear on the podcast, please subscribe, rate, and review the show on your favorite podcatcher. Thanks so much for listening, and catch you next time.